Now that you have learned the basic tools of geometry, let's start using them. This lesson is about measuring segments and angles. What better way to do this than to find and compare lengths of segments and measures of angles? We'll do this using number operations to find and compare lengths of segments and angles. Basically, that involves subtraction and absolute value. We'll start off with the very postulate that allows us to find the length of a segment, the ruler postulate. All that it says is that every point on a line can be paired with a real number. This makes a one-to-one correspondence between points on the number line and real numbers. That's much easier to understand if we have a ruler. And presto, the wonder of technology. You can see on the ruler that each of the points is associated with a particular tick mark, and that tick mark has a number value to it. Now let's look at our first definition for today. The coordinate is the real number that corresponds with a point. So you'll notice here that A is right on the edge of our ruler. So we can say that the coordinate of A is 0, or even 0 inches if you wanted to talk about the units that we're using. Point B is at this tick mark. Well, if each tick mark is 1/8 of an inch, then B is 1, 2, 3, 4/8 of an inch, and 4/8 reduces to 1/2. So the real number associated with B is 1/2. And finally, we have C. You'll notice that C is 1 inch and one more tick mark. So that's 1 and 1/8 inches. Or some people will say that's 9/8 inches. It's the same number, it just looks different. And it might be easier if you get used to the idea of writing your fractions as improper fractions. It makes math a lot easier. Our next definition is exactly what we want to do with segments, and that is measure its length. Length and distance are very similar. The distance between 2 points is the absolute value of the difference of the coordinates of the 2 points. So once again, our coordinates are necessary. I'm going to use variables for the coordinates instead of numbers on this problem so that we can see exactly what is happening. So let's look at point A and point B, and we'll give point A the coordinate of A and point B the coordinate of B. Now be very careful. Notice that the point name is uppercase and that the coordinate is lowercase. Uppercase letters are names, and lowercase letters are variables. That's very important to know. To find the distance between A and B, written as A, B, notice that there is no symbol above it. There's no segment symbol, there's no line symbol, no radius symbol. It's just simply the 2 letters A and B. When we use them like that, we're talking about the distance between 2 points. That is going to be the absolute value of the difference of the coordinates. So there is a formula to help you find the distance between 2 points. Let's try this. What are the coordinates of W and X? Well, all that we have to do is look at our number line here, and we can see that the coordinate of W is -6. And we can see that the coordinate of X is +6. That's easy enough to do. So the next question is, what is WX? Now keep in mind, since there is no segment or line or ray symbol above the letters W and X, they are talking about the distance between them. So the distance between W and X is going to be the absolute value of their difference, of the difference of their coordinates. So that would be the absolute value of -6 minus 6. Wx, or the distance between Wx, is going to be the absolute value of, remember to add to the opposite, so -6 plus -6 is -12, But the absolute value of any number is never negative. So the absolute value of negative 12 is a positive 12. Wx, or the distance between Wx, is 12. This time, try it on your own. What are yz and wz? Press pause. When you have your answers, press play and check and see if you're correct. So you have your answers. Let's see how well you did. The distance from y to z, also known as yz, is a positive 21. Now let's look at wz. Wz is positive 36. How did you do? Now that we know how to measure segments, let's talk about angles. First, what is an angle? An angle is two rays with a common endpoint. We have ray AC and ray AB, and point A is their common endpoint. The rays, ray AC and the ray AB, are known as the sides of the ray, and point A is known as the vertex. There are three ways to name most angles. The first way is simple. If there's only one angle at the vertex, then we can name the angle using the name of the vertex. So we can call this figure angle A. Notice the angle symbol appears in front of the letters. Another way that we can name a ray is by using 3 points. What we do is we choose a point on each ray. Here's point C and point B and the vertex as well. And then we name the point as if we were tracing the angle. So therefore we can start at C and go to A. So we have the angle C, A, and then we can go from A to B. B. Therefore we have angle CAB. A very, very, very important note here. The vertex must be the center point. It's the end point that connects the two rays, so therefore it's in the middle of everything. Another way to name an angle is by using a number. Every once in a while you'll see a number on the interior of the angle next to the vertex. And so you can use that number to name the angle as well. So we can call this angle 1. Now that we know what an angle is, let's look at the plane in relationship to the angle. The region containing all the points between the two sides of the angle is called the interior. I like to think of the rays as being arms, and the interior of the angle is anything that you can reach out and hug. So the green region here represents the interior of this angle. Obviously, if we have an interior, we also have an exterior, which is the region containing all the points not between the two sides of the angle. Using the hug analogy, that's everyone you can't hold into your arms because they're off to the side of you or behind you. So the yellow region here represents the exterior of the angle. Because we need a way to measure angles, we now have the protractor postulate, which says that every ray that shares an endpoint with a given ray can be paired with a real number. And that makes a one-to-one correspondence between the rays creating the angles and the real numbers. Yeah. I think this will make a lot more sense if you can see a protractor. Isn't technology wonderful? You can see here that there are numbers associated with the ray BC. There is both the number 150 and the number 30. And here, associated with the ray A or BA, are the numbers 40 and 140. And we will talk about what they mean and how we use them in our next example. Just like we can with segments, we can also measure angles. The definition is very similar too. The absolute value of the difference of the real numbers paired with the two rays on the protractor. Let's say that the number associated with ray BC was lowercase c, and the number associated with ray BA was lowercase a. Then the measure, that M there, that italicized M means measure, of angle ABC BC is equal to the absolute value of the difference of the two coordinates A and C. Now that we know how to measure angles, we can talk about their measures and classify them. Here we have an example of an acute angle. What that means is that its measure, in this case x, has to be between 0 and 90 degrees. It cannot be 0, and it cannot be 90. 57 degrees is an acute angle. 89.75 degrees is an acute angle. The reason it can't be 90 degrees is because if it is exactly 90 degrees, we have what is called a right angle. So here x is equal to 90 degrees. Now what you see down here, this little box, if you will, is a way that people will mark their figures so that you know that it is 90 degrees. Remember, 89 75 of a degree is very close to 90 degrees and will look like 90 degrees. So the only way you will know for sure that it is 90 degrees is if it has this little box right there. Now let's go beyond 90 degrees. If we go beyond 90 degrees, we get what is called an obtuse angle. An obtuse angle is an angle that has an angle measure greater than 90 degrees, but less than 180 degrees. And finally, we have the straight angle. A straight angle is an angle whose measure is exactly 180 degrees. Now we learned about a straight angle last lesson, and we learned that it creates a straight line, hence straight angle. To do this is to actually trace the angle. This is the same idea as simplifying the figure. So our angle here is angle LKN, this angle right here. Now this is where these numbers come in handy. If you notice, the number right here that I just covered up on the outside is 0 degrees. Now we're going to use the outside number here on ray KL as well. And you will notice that it's halfway between 140 and 150, making it 145 degrees. Now we can use the definition of the measure of an angle. So the measure of angle LKN is going to equal the absolute value of the difference of 145 degrees and 0 degrees. That, of course, is 145 degrees. Now, 145 degrees is over 90 degrees and less than 180 degrees. So angle LKN is an obtuse angle. Now let's look at angle JKN. Let me erase what I have here. So here's ray JK and ray KN. So this is our angle that we're looking at here. Notice that it doesn't matter which order you put these numbers in, 0 or 90, because the absolute value takes care of everything. The absolute value of negative 90 degrees is going to be 90 degrees. And an angle that has a measure of 90 degrees is a right angle. So there you have it. Go ahead and press pause. Do this question on your own. And when you have your answers, press play to verify that you are correct. So you have your answers, do you? The measure of LKH should be 35 degrees, which makes it an acute angle. The measure of angle HKN should be 180 degrees, making that a straight angle. How did you do?